Hello everyone, welcome to the new channel Resultant. Right? So good evening everyone. फटाफट कमेंट बॉक्स में बताएंगे कौन कौन अवेलेबल है यहाँ पे. वेरी गुड इवनिंग टू ऑल ऑफ यू. I hope I am audible and visible to all the persons. Hello. Yeah. So today we are going to discuss about friction, and we are going to discuss some concept. What is friction? What are the types of friction? Magnitudes of friction? And then we are going to solve some problems which have been asked in GATE in past years. ओके सो फटाफट कमेंट बॉक्स में बताएंगे मुझे कौन कौन अवेलेबल है. हेलो एवरीवन, वेरी गुड इवनिंग टू ऑल ऑफ यू. लेट मी नो इन द कमेंट बॉक्स. सो those who don't know me, my name is Vaibhav Singhania. I have done my BTech from IIT Kanpur, qualified GATE with AIR 49, AIR 304, also qualified IIT JEE, right? Teaching experience 7+ more years. So concept, area of expertise, you can see here: engineering mechanics, fluid mechanics, hydraulic machines, soil mechanics, OCF. And I'm going to guide you right here at the resultant for engineering mechanics, fluid mechanics, OCF, soil mechanics, right, in your upcoming preparation. So you can ask questions here. You can also ping me on WhatsApp group of resultant. Right, so crash course is available for GATE 2025. Who are preparing for GATE 2025, they can join this resultant crash course. You can see the faculty available in the crash course is shown here. The thoroughly guidance will be available for all of you in this crash course of civil engineering for GATE 2025. Right, so this is my schedule, class schedule. The first class is today of friction, 11th September. Then the next class will be day after tomorrow in 13th September, and after that it is on 26th of September, which is laws of motion. Okay everyone, so today we are going to come with Richa ma'am and Abhinav Negi sir in 10 p.m. as well, right? So you can join all of us in 10 p.m. session of today, 10 p.m. tonight. Okay, so there will be some huge announcement in the 10 p.m. session of today. As you can see here, Abhinav Negi sir may be making some huge announcements for all of you. So let us come to the topic of today, which is friction. So फटाफट कमेंट बॉक्स में बताएंगे कौन कौन वॉच कर रहा है सेशन को, who all are watching the sessions, and then we are going to discuss about the topic of today. Right, so what is friction force? So friction force is actually basically an electromagnetic force that acts between two surfaces. Okay, whenever any two surfaces which are in contact, then the charged particles of the surface, right, who are in contact, the charged particles, they are actually going to act, and they are actually opposes the motion that is present in the contact surfaces, right? So it is a kind of electromagnetic forces. You can see here in the diagram that this is the one diagram, as you can see. Yes, just a minute. Yes, so this is one surface and this is another surface. You can see the kind of interlocking. This is a very microscopic level picture of the contact surface. You can see there is a kind of interlocking that exists between every surfaces, and when you try to actually move one surface with respect to other surface, or when there is a tendency of motion, or when there is an actually a motion, right, friction surface acts, and it is developed because of the electromagnetic interaction between the contact surfaces. All the charged surfaces, or all the contact surfaces, have actually charged particles, and these charged particles right? Apply forces which is parallel to the contact surfaces, right? So you can see here the friction forces are actually equal and opposite in nature. ठीक है everyone? Right. So these forces, these friction forces, it can act between any two solids, between solids and liquids, and between two liquids as well. You might have heard of viscous forces, right? Viscous forces. So viscous forces is nothing but a type of friction forces. Okay? Viscous forces is nothing but a type of friction forces only. So generally the friction forces are divided into two categories. First is kinetic friction and second is static friction. Right? The study of friction forces can be divided in two categories, kinetic and static friction. Let us all first study about kinetic friction. What are kinetic friction? Generally, the kinetic friction has two words. You all know that, kinetic and friction. So the friction is actually acting between the contact surfaces, which is parallel to contact surfaces, and kinetic means motion, right? Whenever the contact surface has relative motion with respect to each other, the kinetic friction acts. Okay, as you can see here in the slide, it acts when surface slips over each other or actually have a motion with respect to each other, right? So the direction of kinetic friction when both the surface is moving actually is quite tricky, and we are going to solve here, and we are going to know how this direction can be determined. ठीक है? So who all are present, let me know in the live chat or comment box. फटाफट बताएंगे मुझे, thumbs up बनाएंगे, right? Raise the thumbs up in the live chat. Everyone, come on. Okay, right. So kinetic friction acts when surface slips over each other, as you can see, or there is a relative motion between the surfaces, and the direction of the kinetic friction is such that the relative motion between the surfaces are actually opposite. Let us understand by an example. Let us suppose you have two surfaces. Let us suppose you have a block A, and let us suppose you have another block B. ठीक है? This is the contact between the two surfaces. You can see this is the contact point between blocks A and B. Now, how to find out the direction of kinetic friction? Here we are going to learn about direction of kinetic friction. ठीक है? Let us suppose this block B is actually moving with a speed of 4 meter per second, and this block A is actually moving with a speed of 2 meter per second. Let us suppose that. ठीक है? Now tell me in which direction, left or right, the kinetic friction is going to act between A and B. Let us suppose if I ask कि किस direction में, which direction the kinetic friction will act on A. ठीक है? Kinetic friction will act on A in which direction? And second, in which direction kinetic friction will act on B. फटाफट बताएंगे मुझे कमेंट बॉक्स में, एवरीवन, किस किस डायरेक्शन में काइनेटिक फ्रिक्शन ए पे एक्ट करेगा और बी पे एक्ट करेगा. देखिए, लेट अस अंडरस्टैंड दैट. Yes. So see, if I want to find out that in which direction kinetic friction is going to act on A, let us suppose I am going to find out in which direction kinetic friction is going to act on A. Okay? So what I am going to do, I am going to see with respect to B, the motion of A. Let us find out with respect to B, A is moving in which direction. I am going to observe A with respect to B. So B is moving in 4 meter per second towards right. So with respect to B, velocity of A with respect to B, you all know that it is velocity of A minus velocity of B with respect to ground. These all are velocity with respect to ground. VA is 2 meter per second and VB is 4 meter per second, right? So you can see here it comes out to be minus of 2 meter per second. Velocity of A with respect to B comes out to be minus of 2 meter per second, which means that it is moving with 2 meter per second and it is in the left direction. Because positive sign which we have used, plus 2 plus 4 towards right, because the motion is towards the right, and positive sign which we have used is depicting the rightward motion. So it comes out to be negative, which means that the A block with respect to B is moving towards left. So with respect to B, A block is moving towards left with a velocity of 2 meter per second. This A block is moving with a velocity of 2 meter per second with respect to B. Okay, everyone. Now, what we have learned in the previous slide, that the direction of friction force is such that the relative motion is actually being opposed between the surfaces के बीच में जो relative motion होगा, the relative motion exists between the surfaces is actually opposed by kinetic friction. Now you can see with respect to B means the B is actually at rest. If I am observing with respect to B is at rest, right? This velocity 2 meter per second with respect to B means actually B is at rest. So when B is at rest and A is moving towards left, you can say that to oppose the relative motion, the friction force will act on A in this direction. Friction force on A will be in this direction, right? And friction force, right, as we have studied, the friction force is actually equal and opposite. The friction force is actually equal and opposite, which obeys Newton's law. It means that on one surface, if it is acting in this manner, then on B it is going to act in this manner. So you can easily find out the direction of kinetic friction by actually, right, making a diagram in which you can analyze it with respect to, relative motion, right? You can analyze the relative motion and you can find out the direction of frictional force in the contact point between the contact surfaces. Here I have, just to conclude the theory of finding out the direction of friction force, what I have done here, I have analyzed with respect to B, right? Because the friction force is always of opposing nature to B. You can also observe with respect to A. कैसे करेंगे देखिए. With respect to A, let us suppose I need to observe with respect to A. So this is my block A and this is my block B. ठीक है? This is my block B. This was moving with 4 meter per second. We analyze with respect to block A. Previously we have analyzed with respect to block B, right? With respect to block B means I have taken block B at rest. Now analyze it with respect to block A. With respect to block A, right? So velocity of B with respect to A is actually velocity of B with respect to ground minus velocity of A with respect to ground. Yes or no? फटाफट मुझे कमेंट बॉक्स में बताएंगे. लेट मी नो इन द कमेंट बॉक्स वेलोसिटी ऑफ V विथ रेस्पेक्ट टू A, velocity of B with respect to ground minus velocity of A with respect to ground. So velocity of B with respect to ground is 4 meter per second. and velocity of A with respect to ground is 2 meter per second, which comes out to be 2 meter per second, and it is a positive value. Positive value means it is moving in the right direction. Initially sign convention हमारा क्या था, right? 2 meter per second, हमने right को plus माना था and left is negative. So it is 2 meter per second velocity of B with respect to A. Now let us find out how to actually draw the figure. See, now with respect to block A, I can make the diagram something like this. This is block A and it is at rest because I have analyzed with respect to block A. And this is block B, 2 meter per second towards right. Now this block is at rest, this is moving towards right. So to oppose this motion, friction force on B will be something like this, because friction always acts opposite to the relative motion. So A is at rest because I have analyzed with respect to block A. As you can see here, velocity of B with respect to block A. Now A is at rest, velocity of B is towards right. To oppose this relative motion, friction force on B will act towards left, and friction force on A, because equal and opposite, Newton's third law, right? It exists between the contact surfaces, and force is applied on the B is towards left and the force is applied on A is towards right. So the same result has come out with respect to B and with respect to A. You can see here, previously we have analyzed with respect to B is at rest, friction force on A is towards right, friction force on B is towards left. Now we have analyzed with respect to A, and friction force on A is towards right, friction force on B is towards left. Same thing, you can do the same thing, you just need to analyze the relative motion of the contact surfaces. Relative motion means you have to keep one object or one contact surface at rest and you have to observe the other surface, and the direction of the motion of the other surface opposite to that direction, the friction force will act. This is the concept of finding out the direction of the friction force. It's very easy, as simple as that. Now the very important question, yes sir, we have discussed about the direction of friction forces. Yes sir, the direction we have discussed about. Now what is the magnitude of friction forces? भाई friction forces का magnitude क्या होगा, ये कैसे निकालेंगे आप लोग? How they are going to find out? So the friction forces magnitude, it means that since the friction forces acts between the two surfaces, the contact surfaces, how hard these two surfaces actually pressing each other, right? How hard these two surfaces are actually pressing each other defines the, just a moment, how hard these two surfaces are actually pressing each other defines the magnitude of friction forces, right? Now this is the normal forces. Let me make you a clear diagram so that you can understand. See, let us suppose this is the one surface and let us suppose it is rested on ground, right? A block is actually rested on the ground. Now we all know that if you're going to diagram, if you're going to draw the free body diagram, this block is at rest. Now the mg, the weight of, because it is this mg, who is actually resisting this mg is the force coming from the ground, which is the normal force. Now this normal force is acting in this contact surfaces. As you can see, this normal force is actually acting here, this normal force is actually acting here, and this normal force defines that these two surfaces, with what intensity these two surfaces are actually compressing each other, how much force exists between the two surfaces. And therefore I say the magnitude of the kinetic friction depends upon this normal force, with what intensity the two contact surfaces are actually going to press each other, right? So we all know that friction force is actually directly proportional to the normal force. Friction force is directly proportional to the normal force, and if we remove this proportionality, the constant of proportionality comes out to be mu k, which is actually coefficient of kinetic friction. Mu k is actually a dimensionless quantity. First of all, remember, this kind of question generally comes in your examination, that mu k is a dimensionless quantity. And sir, ये mu k किस चीज पे डिपेंड करता है? In what other things that mu k actually depends? So since this normal force defines the kind of interaction or the force with which the two surfaces are compressing, the mu k actually depends on the property of surfaces, whether the surfaces are smooth or whether the surfaces are rough. अगर surface smooth होगी, if the surfaces are smooth, the normally friction force will be higher or lower. If the surface is smooth, you can going to easily slide the object very easily. You can going to easily pull the object, or you can go to actually easily push the object if the surface is smooth. It means that if the surface is smooth, friction force is smaller. If the friction force is smaller, it means that mu k is small. Mu k is small. If the surface is rough, it takes a very good amount of force to pull an object or push an object. It means that the friction force is very high, therefore mu k, if the friction force is high, mu k is very high, right? So the friction force, the magnitude of friction force depends upon the normal force, right? And also the type of surface, whether it's smooth and rough, and this property is actually governed by the mu k, which is the constant of proportionality. Now also it depends upon the type of material you have, right? For example, a wood is actually on a water, right? Or wood is actually rested on a steel surface. And the same wood, if it is rested on a concrete surface, the mu k will be different, because the surface is actually changed. Surface is completely changed. So the electromagnetic properties of the contact forces are actually changed. Therefore, mu k also change when you change the material, right? Now, very important thing, very important notes, which is a brainstormer note for all of you, is that the magnitude does not depend upon the area of contact. It's a very beautiful thing that the magnitude of the kinetic friction depends upon the type of surfaces, whether it is smooth, rough, material which are in contact, and the normal force, the force with which the two surfaces are actually compressing each other, right? But it does not depend upon the area of contact. Let me give an example. Let us suppose this is a block A which is resting on a ground, right? Now let us suppose the same block, let me stand it, the same block. If you move this block with a force F, the friction force on this block F, and if you move this block, the same block which is vertically placed, the friction force will be same. Friction force क्या होगा दोनों पे? The friction force will be same. What I am going to tell you is that the friction force does not depend upon the area of contact. It's a very beautiful question, and if it comes to the objective, many students will make it wrong, right? They will easily going to, and if it is asked in interview, many students can be confused, and I can confuse the student by saying, see, the area of contact is actually increased. Let us suppose this is the case A, and let us suppose this is the case B. I will say the area of contact between the ground and the block A in the case B has increased. So more electromagnetic force, more contact forces will be there. Therefore, the friction force will be higher in the case of B. I can easily confuse students in an interview. But you need to understand the frictional forces does not depend upon the area of contact. It only depends. What is the formula? Mu k and n. N is the normal force between the two surfaces, and mu k is the type of surfaces, right? Rough, smooth, materials, right? So it does not depend upon the area of the contact. Now one more thing, the frictional force, magnitude of the friction force is actually fixed. It does not change. It is not a variable force. Whenever an object has a relative motion with respect to another object, the frictional force is fixed and its value is mu k into n. It does not change. Why I am telling you this? Because when we study about the static friction, right, जब हम static friction के बारे में पढ़ेंगे, the static friction is a variable friction. It adjusted itself, right? The static friction adjusts itself depending upon the force with which the object is being pushed or pulled. ठीक है? So always remember, kinetic friction has a fixed value which is mu k into n. It is a fixed value force. Now let us come to our another important part, which is about static friction. This is static, right? Now what is static friction? In the opposite case, we have studied about the kinetic friction. Just opposite to that, kinetic friction acts when there is a relative motion between the contact surfaces, but the static friction acts when there is no motion between the contact surfaces. Let me give an example. Let us suppose this is the ground and this is a big almirah. What happened? It's being smudged. So this is the ground and this is the big almirah which is placed in the ground. And you are here, right? You are actually pushing the almirah. You are actually pushing the big almirah and it's not moving. You are applying a force on the almirah and the almirah is actually not moving. So this force must be resisted by some force, because if you apply a force on the object and it is not moving, it means the object is in equilibrium. And if the object is in equilibrium, the net force on the object is zero. Now who is balancing this force? This force is actually getting balanced by the friction which comes from here, from the ground. This friction, right? And this is in static friction. Why? Because almirah is not moving. You are applying the force and the same amount of force is actually applied by the friction force between the contact surfaces of ground and almirah, which is Fs. The same amount of force is actually being applied. Almirah is not moving. There is no relative motion. If there is a relative motion, the kinetic friction will act. But here there is no relative motion between the almirah and the ground. And if there is no relative motion, the static friction will act. This force is actually balanced by the static friction between the almirah and the ground. Very important part. Very, very, very important part. Right? And I am saying this almirah is not moving. It means the almirah is in actually equilibrium. And if equilibrium, the net force on the almirah should be zero. And if the net force on the almirah is zero, it means that the force acting is your F, which you are applying, plus Fs, which is coming from the ground. Static friction should be zero. Now you can see the Fs is minus of F. What does it simplify, or what does it imply? This value of the magnitude of the static friction is actually equals to F. And can anyone tell me what this negative sign implies? This negative sign implies the direction of static friction. Direction of static friction is opposite of F. Opposite to the F. Very important part, right? Now you can see, अब यहाँ पे समझना बात को, ठीक है? You have started this force from value of 0 to value of 100, let us suppose, and all the forces are actually being resisted by Fs. Let us understand the case. The first case, it's very beautiful. Let's understand this. The first case, this is an almirah. Yes sir, this is an almirah. This is you. Yes sir, this is me. I come and I apply a 10 Newton of the force. I apply 10 Newton of the force. Now same amount of force is actually coming from the ground to resist the motion of almirah, Fs. So in the first case, Fs is actually minus 10, right? Opposite to this 10 Newton, first part. Let us suppose you think, oh, I apply 10 Newton of force and Almira is not moving. So let me increase the force. And in the second case, you apply 30 Newton of force and again Almira is not moving. It means that the Fs, the force resisting this, is 30 Newton. What I am going to tell you, and what by these two cases what I am trying to tell you is Fs is actually adjustable up to its maximum value. Fs is adjustable up to its maximum value. This is very important. This is very important from examination point of view. This kind of question can come in 1 marks objective, that the kinetic friction magnitude is fixed but the static friction is adjustable, and these kind of concepts are actually being used in the numerical to make you do the error in the examination, right? You can see the static friction is actually adjustable. Here you applied 10 Newton of force, the same force applied by the static friction. Here you applied 30 Newton of force, the same force is actually applied by the static friction. So it adjusted, but it is not possible that static friction is going to adjust its value till infinity. If a WWE wrestler comes and he applies 1000 Newton of force, it does not mean that the static friction is going to apply 1000 Newton of force or 10,000 Newton of force or 1 lakh Newton of force. It's not something like that. Fs actually adjusts its value up to a maximum limit. And what is that maximum limit? That maximum limit is mu s into n. So you always remember the maximum value of a static friction is actually mu s into n. What is n? N is actually the normal force, the same force in case of kinetic friction, and mu s is actually coefficient of static friction. The dependency of mu s is same as with the case of mu k. It depends upon the type of surfaces, rough, smooth, and materials in contact, wood concrete, steel, steel, right? These kind of thing, mu s is actually depending. And again, mu s is a dimensionless quantity, very important. It's a dimensionless quantity, pure magnitude value. So what we have learned is that the kinetic friction acts when there is a relative motion between the surface, and the value of kinetic friction is mu k into n, and it is fixed. It does not adjustable. The static friction acts when the two surfaces are actually at rest. There is no relative motion between the contact surfaces, and the magnitude of static friction is actually adjustable depending upon the force which are actually applied on the object. And these adjustment can happen up to a maximum value, which is Fs max, static friction maximum value. And what is the value of Fs max? It is mu s into n. Mu s is coefficient of static friction, which depends upon the type of surfaces, rough, smooth type of material, and it is a dimensionless quantity. So this is the crux of our theory which we had covered today. Now, what is the direction of static friction? We are going to find out the direction of static friction? Can anyone tell me? So the direction of static friction is actually opposite to the tendency of movement of an object. Direction of static friction is opposite to the tendency of the movement of object. Let me tell you. Let us suppose this is a ground, and let us suppose this is a block or an almirah, anything, block A. Let us suppose a force F is applied on this block. So the tendency of the motion of this block A, you all know that if you apply a force towards the right, the block is going to move towards right. So the tendency of the motion of the block A is towards the right, and to resist this, a frictional force on the block A, to resist this, the friction force on the block A will be, you all know that. This is block A. I'm making the free body diagram. So to resist this, a friction force on the contact surface is this. So the tendency of the block A is not moving. Remember, block A is not moving. Students, block A is not moving. It is at rest. But the tendency of the motion of the block A. What is the tendency of the motion? Tendency, if you apply force on the right, the tendency of the block A is to move towards the right. Now to oppose this tendency of the motion, the friction force is actually acting towards the left. Right? So the direction of the motion which is actually opposite to the tendency of the motion of the object as per the applied force. Right? We all know that the friction force is actually what we have studied. The friction force is actually less than a maximum value, which is Fs max. Now for all of you, let's solve a one beautiful question, and I'll give you one question as a homework as well for all of you. A block R of mass 100 kg, is placed on a block S of mass 150 kg. So here it is given the block of mass R is 100 and block of mass S is 150. Block R is tied to the wall by massless and inextensible string PQ. PQ is an inextensible string. The coefficient of static friction for all surfaces is 0.4. All the contact surface has a static friction of 0.4. The minimum force F needed to move the block S. तो ब्लॉक एस को मूव करने के लिए एक मिनिमम फोर्स की क्या रिक्वायरमेंट है, इसको आपको निकालना है. ठीक है. What is the minimum force F required to move the block S? Now let us understand what are the contact surfaces available. So there is a first contact surface happens is actually between R and S. This is by the way previous year GATE question, GATE 2014 question, and this is the block S. ठीक है. So this is your first contact surface between R and S, and इसके बीच में जो static friction की value है which is actually 0.4, and this is the second contact surfaces. यहाँ पे भी जो static friction की value है it is 0.4. Now an force F is actually applied on block S, and it is asking that what is the minimum force F required to move the block S. देखिए कम से कम फोर्स कितना लगा सकते हैं S पे ताकि S मूव कर जाए. Now tell me one thing, that whether from which contact forces this force is actually going to be resisted. Right? First of all, the tendency of the block S. What is the tendency of the block S? Initially the system is at rest, and when you start applying force, the static friction will start acting, right? So if you apply force F on the block S towards the right hand side, it means that the tendency of the block S is to move towards right hand side, isn't it? The tendency of the block S is move towards the right hand side, and this is the contact surfaces, right? To resist this motion, to resist the tendency of the motion, friction force will act here, something like this. Yes or no? Friction force will act here. Now this block S, understand, this block S will actually wanted to move towards right. This block S wanted to move towards right. Now there is a relative motion. If the block S is moving, there is a relative motion happening between R and S, and S is actually trying to move towards right. So to resist this relative motion, the friction force here will again come in this direction, right? ऊपर वाला जो block है, that R is actually going to resist the movement of S. And in what way? How R is going to resist the movement of S, right? Because initially both the block is at rest and the contact surface is actually going to resist the motion of S. So the contact surface with the ground, it is going to resist by applying force F in the opposite direction. The contact surface with R is going to resist by applying a force F in the opposite direction. This is the concept which we have studied, right? All the contact surfaces are actually going to resist the motion of S, right? If the friction force on the F is on this direction, then the friction force on R will be in this direction. Yes or no? Equal and opposite, Newton's third law. Now, to find out this minimum value, this value with which it can actually just able to move the block S, what we are going to do? Right? What we are going to do? We are going to find out the maximum value of these two forces. Right? If this forces is actually above the maximum value of this contact forces, S is going to move. Very easy. Obviously, if the applied forces is just greater than or equal to the resistive forces, if the applied forces is just greater than or equal to the resistive forces, this S is going to move. And what are the resistive forces? These two friction forces, right? And maximum value of resistive forces, you can also write it maximum value. The maximum value, if the applied force is actually greater than or equal to maximum value of resistive forces, the block is going to move. So let us give this Fs max 1, this is Fx max 2. So calculate Fx max 1. What is Fx max 1? Is actually mu s into n, right? Mu s is 0.4. And what is the normal force between the first surface, between this and this? What is the normal force? R is actually of 100 kg. It means that there is 1000 Newton of downward force coming, 100 kg. G की वैल्यू मैंने 10 ले ली, G की वैल्यू 10 ले ली, right? या you can say 100 G of forces is actually downward gravitational pull. 100 G Newton of force is actually gravitational pull, which is balanced by this normal forces on R, and the value of N1, let us say it is N1. N1 is equals to 100 G. So यहाँ पे आप इसको use कर सकते हैं, it is 100 G. It comes out to be 40 G, Fs max 1. Now Fs max 2 is mu s into N2. Let us suppose this is N1 and this is N2. Now you can see this ground is actually balancing both the object. If I take, see, if I take this as a system and both the system is actually, the weight of both the block is actually balanced by the ground. So you can say the ground is applying a total weight. Ground is resisting both the block. So the total weight of 250 kg. So 250 G. So the value of N2 becomes 250 G. So 0.4 into 250 G. This value will become, कितनी हो जाएगी? 100 G. So Fs max 1 plus Fx max 2 comes out to be 140 G. Fs max 1 plus Fs max 2 will comes out to be 140 G. Now if I told you applied force is greater than the maximum value of resistive force, the block S will move. If F is greater or equals to 140 G, the F will move. Here question has asked in kilonewton. In question it has been asked in kilonewton. This we have calculated in Newton. So let's divide it by 1000 to get in kilonewton. It will become 0.14 G kilonewton. If I take the value of G as 10 meter per second approximate value, it becomes, if F is greater than or equals to 1.4 kilonewton, the block will move. Very easy, very easy. Right? If F is actually greater than 1.4 kilonewton, the block will move. This 1.4 kilonewton comes out when G is 10 meter per second square. Right? So when G, you can take G as 9.8 meter per second square, you will get a just less value than 1.4, and just value less than 1.4. From this option you can see it's D, 1.37. Right? So in this way you are going to solve this kind of question when it comes in the examination. So today we have covered about what is frictional force. Frictional force has a tendency to act opposite to the direction of motion between the contact surfaces. It always has a tendency to act against the direction of motion of the contact surfaces. right? Friction force is a type of electromagnetic force which is acting always parallel to the contact surfaces. Two types of friction force exist, kinetic friction and static friction. Kinetic friction exists when there is a relative motion between the contact surfaces. Static friction when there is no relative motion between the contact surfaces. Then the static friction act. Static friction is an adjustable friction. Kinetic friction has a fixed value, right? Mu s and mu k are the coefficient of static friction and kinetic friction respectively, which depends upon the type of surfaces. And this is the one beautiful question which we have solved, which has been previously asked in the GATE examination. This is the one more question which is in homework for all of you. Solve this question, and when we will meet in the next class, we will solve this question, right? In the next class, we will start by solving this question. So this is homework for all of you. In our next class, we will start by solving this question, right? You can also let me know the answer in the comment box as well. तो आप comment box में अपना answer बता सकते हैं. And please let me know in the comment box how did you like the session. If you like the session, put a thumbs up. Do subscribe the resultant channel. And if you are seriously preparing for the examination, do buy the crash courses or the regular courses of resultant, which is a dedicated team of faculty for the GATE examination, right? So if you are willing and if you are preparing seriously for your examination, do buy, right, resultant civil and resultant mechanical courses for GATE, ESE and PSUs. So thank you everyone. We are going to meet at 10 p.m. with Richa ma'am and Abhinav sir again, right, in this platform. So thank you everyone. Thank you very much.